Gaan we.
Yeah, good to go?
Yeah.
Okay, awesome. All right, welcome. Thank you all for joining this workshop. My name is Victor, one of the founders, CTO at UbiOps. My colleagues joining me is Anouk.
Hi.
She's our product owner. And well, today this workshop is about deploying a computer vision model in the cloud. And let me first give you a bit of an introduction, and maybe let's ask a question. So, who's built a machine learning model before? So, who is like an AI practitioner? All right,
Cool.
big group, great.
Nice.
Who actually deployed this model to production or is using it as part of an application?
Oh, that's a pretty good score, actually.
Good score.
Yeah.
Okay, quite a few hands. Right, that's great. And yeah, actually going from building a model to deploying a model, that's what we're gonna talk about today. Let me quickly introduce our platform. So we're building UbiOps. It's technology for running and deploying AI machine learning models at scale in the cloud. So we really build it for data scientists to make the transition from having a local model or from your development environment to a deployment in the cloud that runs at scale and kind of has you a reliable service that you can use in the background of an application or service for which that AI model is a big part. And we try to do that in a very user-friendly way. So today I give a quick introduction about our platform, talk a bit about model serving deployment in production and some challenges that we cover, and then I give the floor to Anouk, and she will show you how to actually do this deployment of a computer vision model with our platform, and yeah, hopefully, yeah, it will be. You can learn from that. We'll have some Q&A at the end, so also happy to get any feedback or any ideas on yeah, what your experience is with deploying machine learning, and getting it from the lab to the field. Right, let's get started because that's what we're going to talk about. So how to get machine learning from the lab to the field. So how do you make the transition from actually doing the data science, AI, machine learning development to actually getting some value for the business because you integrate AI or machine learning in a product or in a service, because that's the point where it actually starts adding value for a business or for a company. But it's also a point that's kind of hard to reach for many companies. Why is that? Because well, just running a machine learning model on your laptop is quite easy. And also having a Docker or a virtual environment on your laptop is quite easy. But what about if it actually runs in the background of an application? Then you have to think about things like reliability. This stuff needs to run 24/7. If there are many calls to the API or a lot of data flowing through it, it needs to still be available. It needs to scale. Stuff needs to be secure. How do you maintain a model that's actually running in production? So you don't want to touch it, but you have to touch it. What do you do? How do you get enough compute power? How do you get enough resources? And how do you, lift and shift workloads? How do you run it in an environment or a cloud that the user or the customer wants? And there's a lot of things to think about, and that actually makes this kind of simple sounding problem of just running the model in the cloud. It actually makes it a very complex task. So usually it sounds kind of easy, like you develop it in a Jupyter notebook, Dockerize some things, run it on a VM, that's it, you leave it alone, add a Flask API, and there's your model. But if you actually want to run things behind applications that need to be available 24/7 and where users actually count on, then it becomes a whole different exercise, and you encounter a lot of different things. You probably touch Kubernetes, Git for some CI/CD, work with different cloud services, work with databases, work with server scalability, and that road to getting something to production actually becomes quite hard, especially for data science teams who don't have that computer science or IT knowledge to really do all that cloud engineering and especially maintain it. I mean, it can be fun to play around with it, but yeah, who they're going to call when it's breaking and it's 3 o'clock at night. So we take care of that by just having an out-of-the-box platform to actually do this and manage models in production, help them scale, and basically take care of all that difficult stuff, so data science teams can just focus on building the models and building the applications. Right, let me give you an example of a company we work with, and then slowly go from there to what we're going to do today. We work with Bayer. Bayer is a big pharmaceutical company. They also do a lot in agriculture. We work with their crop science department, and they're building an application for crop growers and farmers where they can actually detect diseases and pests in their fields, in their crops, and they're doing that. They're offering it as an IoT device with a camera on it, but they also have a mobile app. And all that stuff ends up in their, well, they're building AI models to do this. That's their core IP. But of course, they want to build this into a whole service that they can actually sell to farmers and crop growers. And well, kind of the architecture basically sounds quite easy. So you have an end user, that's this guy with his mobile phone, and he's taking a picture of a plant which he suspects that something's wrong with it. It gets sent to this application, and in the background this AI model needs to run, and it needs to send a response back, and that response needs to end up at the farmer. So that goes well if you send like one data point, there's one service running. If this guy's sending a lot of data points, then probably something breaks. And as I was just saying, to really get to the point where it's actually scalable and reliable, you not just have that AI model, but you have all these services around it that really turn this journey into quite a complex IT engineering and cloud engineering challenge. So that's what we're solving for them. So what we're doing is they can land their AI models in our platform. We give you an API. They have their application. They connect the two together, and actually now they have a scalable backend with their AI models running in it, so that their end users are actually happy and can actually send a lot of data. And because of these type of applications, like this is, for instance, very seasonal. So some days or some months there's a lot of traffic. Some days there's no traffic. Also depends on the region in the world. They sell this worldwide, but now they're mostly in Europe. So at night there's actually nothing happening, but during the day a lot of stuff is happening. And also this all runs on GPUs. So all this like image recognition stuff runs on GPUs. So yeah, that's also something that we, of course, need to care about because it's expensive hardware. So yeah, it doesn't need to run all the time, but it needs to scale, and that's what we take care of. And we also work with companies like NVIDIA and cloud providers to make sure that this kind of scales on demand. So we also add on-demand compute to these challenges and the mix. So yeah, in general, like this machine learning model ops challenge, this MLOps challenge, is kind of in the middle between data science and cloud infrastructure. So that's also where we position ourselves. So we want to leave enough flexibility to the data scientist to actually use the tools and the frameworks and the dependencies that they like, but we are the interface between that and the cloud infrastructure underneath to make sure that everything runs. You can actually use it in production. So what happens in the background? We take care of Dockerizing your code and all the dependencies. We use Kubernetes to scale it. We do API management, so actually each model, each pipeline gets its own API endpoint that you can connect to an app. But you can also schedule these. You can also schedule runs and schedule jobs. And also important, we take care of authentication, security, reliability, and also give you a way to manage these services and manage these models when they're actually running live in production, so that when you have to update a model, you can actually create a new version and have like a seamless transition between the existing model that's running behind that endpoint and the new model. So all these type of things that you actually need, but that you don't want to, yeah, break your head on these challenges as a data scientist or data science team. Yeah, a bit of the architecture. So we have Kubernetes. There's a UBOps control plane and an API. And then that's like the Kubernetes is the part where all the kind of the AI workloads live that we call deployments. And on top of that, we have a set of services that take care of all the governance and management. So we have model management like version control, file and object storage for some data management. We have workflow orchestration, nice user interface, logging and monitoring. And we also support like multi-cloud strategies. So you can actually say like, hey, we can attach different node pools to this main cluster and can say like, hey, we have a node pool that's specific for like GPUs or with specific instances. You can say like, hey, these workloads need to run there. So you can point them to that cluster. Or if, for instance, with Bayer, they want to have all their compute in Europe, or they have like specific needs for where things need to run, that's also stuff we can take care of and orchestrate in that way. And UBOps does the heavy lifting and the orchestration. Right, so bit back to the topic of today, deploying computer vision models. We see a lot of our users actually deploying computer vision apps, because it's also one of the areas of AI that's currently probably at a point where running it in production makes a lot of sense. And a lot of it is computer vision. So that's what our users mostly do. And how that actually looks like on UBOps, that's what Anouk is going to guide us through. Maybe we do a very quick round of questions.
Yeah.
Okay, before we go to the workshop, any quick questions on? Yeah.
Oh, I think there's a microphone coming towards you right at this moment.
It's being recorded, so it's, I can hear you fine.
Okay, for UBOps, actually, I see this as an interface, but we already have Azure Cloud as in our organization. And we have like this OAuth 2 in front of it. So Okta verification has to happen there. So is it possible to integrate UBOps in our existing cloud platform?
Yeah, so we're cloud agnostic, so we can run on Azure as well. And we can actually also fix the authentication that you can actually have, UBOps users from your like Azure authentication or whatever authentication.
Like identity propagation.
Identity, yeah. Okay.
Any other questions so far?
We also have time at the end, so also.
Okay, cool.
Okay.
Because of course, like this is the track 6 part, I believe, of the World Summit AI, which is centered around some workshops. So we just wanted to show you how this actually works in practice. And I think also the talk was titled like deploying a computer vision model to the cloud. So that's exactly what we're going to show you. Like, how does that work when you're using UBOps? Like, what kind of workflow is it? And I think it's also important to emphasize that, of course, even though we're very focused on our platform specifically, I do think that the main best practices that we try to practice using our product is also transferable to any of your own stack, even if you already have a complete tool set for this. So what are we actually going to do, or what are we going to build? So we have pre-trained a computer vision model already because we didn't want to focus too much on that, and training can take a bit long. We use the MNIST dataset, which probably some of you are familiar with. Yeah, I see some nodding heads. I think it's like the like point of entry for any data scientist is to work with the MNIST dataset at least once. So it's this dataset of handwritten digits, and the model that we train is one that can or takes an image of a handwritten digit and predicts what digit it is. So pretty straightforward use case, and we just want to show you like how do you actually put this on the cloud to a point where you can start using it, where you can start sending data to it and make it scalable essentially. So we take the pre-trained neural network and we're going to deploy it on UBOps using Python. So that's what I'm going to use today. Essentially, the steps for this is we're going to write some code, or actually I've written some code that I'm going to show you, for actually calling this AI model to put it or to package it in a way that UBOps can handle it, and to send some data to the API endpoint that will pop out. Now, I am going to use Python or the Python client library for today, so I'm going to show you a notebook in a bit that I will run you through. But this isn't the only way of working with UBOps. Like, you can also work with the web app and do everything visually that I'm going to show you, and I'll also show you in a little bit like how that actually looks. But yeah, this is basically the setup that we have. So we have this number image. So on the left, we have an example from an example handwritten digit that we pass as input to our deployment. That's what we call them on UBOps. And then an output will come back like, this is a 5 and I'm 96% sure, or like, how sure is it of its prediction? That's what we've built. Yeah, so maybe first, what are those deployments? Because, yeah, very fun that we're going to put something on there, but what actually is a deployment and how do we define them? Essentially, deployments in UBOps are any piece of code that takes input and transforms it in output. That doesn't necessarily have to be a computer vision model. It's just the example that we're using today. This can also be a data pre-processing step, for instance, where you're just putting in raw data and you get out clean data. Can be a training job, can be a trained model like we have in this case. Essentially any piece of Python or R code. That's the only constraint. It needs to be Python or R, otherwise we don't support it. So some examples are also listed on the slide. Now, conceptually, this has some kind of things that I think are important to note as well. So we have this deployment, and how you create one in UBOps is that you have the high-level deployment, which is kind of like a definition of what input am I expecting and what output am I expecting. So in my case, I'm expecting an image input and a prediction output. Under that deployment, we can have multiple deployment versions. So we can have different implementations in terms of code that performs the same input to output step, essentially. So for instance, differently trained models that are used for the same function. And those deployment versions then have revisions again for when you override something, but I won't talk too much about that. And you can make one of your versions the default version. This means that it has one generic endpoint that will stay the same. Regardless of which version you pick, it's just one default endpoint so that you can use in any other part of your stack that you're calling your model with. What that means is that whenever you create a new version, you've retrained your model and you created one that was a bit better, you don't need to update how that model is being called in any other part of your service. So in the Bayer example where they have the mobile app, the way the mobile app will call on that model will stay exactly the same because it will just always call the default. And whenever you're ready to switch your default, you just switch the parameter and you don't have any downtime essentially in between there. But I think that's enough background knowledge, and I think it's just better to show you how it looks. I need to look here because I don't have it on this screen, so if you see me like this, that's just because I'm trying to read the code there. So bear with me a little bit, okay? Can I zoom in here, or
I think
does
so.
that work? Yeah. Okay, because then I think it's also a bit more readable for you guys. I've got this notebook in Google Colab, which most of you are probably, familiar with. Just to show you kind of like what the steps are to go through, and also to make sure that you can actually see the code that I've written, like what the model is, what is actually going to UBOps. So first things first, and we need to install the client library that we're using. So we have a UBOps client library, which basically makes it a bit simpler to interact with our API through code. So I'm just quickly gonna run that one. Wait, does that? Yeah, that's fine. Okay. And we actually had a link because it was intended as a workshop, but we don't have tables, so it might be a bit tricky. But if you want to follow along, by the way, then we do have a link to this notebook, because I see some laptops. So if you want to do that, this is the tiny link that you can put in for the ones that have the laptop. Then you can actually see what code I'm running as well. So I'll just leave it here. I forgot that for a second.
We can leave the notebook live after the
Yeah.
demo as well. So if you can try it at home, it's publicly available,
Yeah.
and it won't sync, generally sync the changes. So you can just have your own
Yeah.
private version of it.
Exactly.
It takes you to the basic steps.
Yeah.
One thing that you're probably
Yep.
gonna tell that anyways.
No,
About that you need a user account.
Yeah.
Because we're gonna authenticate with the UBOps API. So with our Python client, so you need to create a user account and then create a token
But
to
I'll
authenticate
show how
with
to
the
make the
API.
token
But
with it.
pretty straightforward.
Yeah.
And then,
Okay, so that's that. And yeah, okay, cool. And I'm gonna hop back again to the notebook, but as said, we'll keep it live so you can also watch like on your own time afterwards. Okay, so I've installed the UBOps client library. Now, I need to define some info about my project to be able to say like where does this need to land inside UBOps, because otherwise we can't just be shooting off models into nowhere, like it needs to end up somewhere. So to do that, I'm going to also quickly go to the web app. So this is what our web app looks like. So maybe go a bit more zoomed in as well. That's maybe a bit better. So this is the visual interface essentially for UBOps, and I've already created a project. This is just my own project, and I want to make sure that the computer vision model I'm going to make that's going to land inside this project. So what I need to do to be able to do that through code is that I need something called an API token. So I can go to permissions, and then go to API tokens, and then I can create a new token that I can use to be able to interact with the API directly. So I can click Add Token. Just need to give it a name, so I'll give it World Summit AI. Expiry date, set it to expire, because all of you are going to see my token now, and I don't want all of you to be able to do something in my project. So it will expire. And then I'll just go to the next step, and then I can assign some roles to my token. So essentially, like, what is my token allowed to do? Well, in this case, I'm really going to make like a deployment and do a bunch of stuff with that. So I'm just going to give it project editor role, so that basically gives it a lot of permissions. But if you need something very granular, for instance, to really only be allowed to make a request to a specific model, you can also put that in there. But for now, I'm just going to give it a bunch of rights so it can do everything with it. Okay. Then I have here my token, so I'm going to copy that one, go to done, and then we can hop back to the notebook, because now we essentially have everything. We have a project and we have an API token. That's what we need. So now when I go to this section where I'm defining my project variables, I need my token. So I'm going to put my token in here. See? Yep. Okay. And I need my project name. So I already have my project, and my project was called Anouk Test Project. Should be that one. And I've just got some other variables that I'll need a lot throughout the code, like what name I should give my deployment and what version. And that's it. And then with those variables defined, I can now initialize the client library and set up a connection. So if I run this cell, see? Yeah, it gives me back status OK. So I've got a connection set up to the API right now. So I'm allowed to do stuff in my UBOps project right now. So then the first thing we need to do is to actually create a deployment. So this is that step that I was talking about earlier. I need to define, like, what is the input that's going to go into my code, and what's the output that I'm expecting. In my case, I'm expecting an input called image, which is of data type blob, so any type of file. And my output is called prediction, and it's of data type string. It's just a string that's saying this is a 5, and I'm so certain of it. So once I have that, I can run that too. And now we get back that this is created. So now when we hop over to the web app, we should actually be able to see that. Yeah, so here we see it, the MNIST 2022, and then the 12th of October. So that's the one that we just created. So when I go to this one, you can see it doesn't have any version yet. It's just here in my project. So when I go back and go to the next cell, I can actually start preparing my code, so my code implementation to create a version of this deployment that actually transforms this input image into some kind of output string that I need. So I'm going to quickly make a folder that my notebook can go to, where I'm going to store my deployment files. And I'm just going to generate them from the notebook so you can see like exactly what the code is. Because for something to run inside UBOps, there's one main file that we will always need. And that's your deployment.py or deployment.r if you're using R, which basically gives us the main instructions on what to do when we initialize your deployment and what we do whenever there's data sent to the deployment. So when you look inside, it's a bit sad that the code highlighting for this cell doesn't work, but you can see that I have a class called deployment with two functions, an init function and a request function. The init function will be called whenever my deployment initializes, so this is handy whenever you have anything that needs to be kept inside main memory. So like that doesn't change from request to request. In my case, that's handy because I've got this pre-trained model, this neural network, which is this CNN.h5 file. I'm just going to load that in my init function. So I only need to load it once, and then for every request, it's ready. So that's what I'm doing here. I'm loading in my weights so that my model is ready in the init function. And then in the request function, that's typically where your main chunk of code will go. So in my case, I get past this image, which I get through this data variable. So I will read in my image. I'll reshape it a bit so that it fits for my model, and then I'll just call the model predict function on that image, and from that I get a prediction with a certain percentage of how certain I am from it, but also like what it actually is, what our prediction is. And then when I have that, I'm going to return that as a dictionary here. And you saw that I defined like my output is called prediction. So that's what I need to return here. I'm returning a dictionary with key prediction and with value result. So that's my actual value that I'm returning. So that's what my code looks. So if I run this cell now, that will basically create this deployment.py file and put it inside that folder that I created earlier, the deployment package folder. So I think now also if I look here, yeah, you can see it. I have here this folder deployment package and my deployment.py is in there. That's the one I just created. So that's the number one file we will always need. But now typically to run Python code, you have some kind of dependencies. And of course, we need to know what kind of dependencies is your code using. So to be able to do that, we just utilize a requirements.txt, so nothing funky that we're doing there, pretty standard stuff. So I've got here my requirements that this piece of code needs. So when I run this, it will also create a requirements.txt in this folder with the dependencies that I have. Okay. Now, typically this would already be enough, but in my case, I also have this trained model that I actually need to put in my package, or I would need to dynamically load it from object storage somewhere. But I'm just going to put it in the package because it's a bit easier for now. So I've got it stored on cloud storage now so that when you run this yourself, you can also have access to it, but I'll run it here. And this will also just copy it over to the deployment package to make sure that it's there, I think.
You could also, if you want, you can also load it straight into the main function of your init function of your deployment. You don't have to ship it, like upload it with the package. But if you, for instance, have use object storage for storing like model or parameter files, you can load it straight from there into the code.
Okay, so now I've got my package fully ready. So this is everything I need for uploading it. So this is how we need to package it, and now it's ready, so we can actually create that version now and push that code to UBOps. But any questions so far about the deployment template? Anything unclear about that, or is that pretty understandable? Yeah?
What if you have your code elsewhere?
You mean in GitHub or something? Or yep, good question. We offer some templates for CI/CD pipelines so that you can automatically deploy from GitLab or GitHub directly to UBOps, because we also have a command line interface that you can pretty handily use in those YAML files. Like if you have a CI/CD YAML, then you can pretty much just call the UBOps API and say like, okay, here's my package, it's in this repo at this position, put it inside a deployment package. So then you can manage your code from GitLab or GitHub or Bitbucket or whatever you're using and use these CI/CD pipelines essentially to push it.
There's also another way, like we're doing it from the notebook right now because it's self-contained and it's easy to follow. Of course, if you have this code on your laptop, you can just package it and upload it through our UI or, kind of use the Python client to do so.
Okay, cool. But yeah, now it's ready, so we can make that version. So to make a version, essentially we just need to upload the code and provide what kind of language it's written in. So what Python version or what R version. That's what I'm defining here. So when you look at this function, it's like a deployment version create. I'm passing it what version name I want to give it, which language. I'm using Python 3.7 here. My memory allocation, so this is in megabytes. And minimum and maximum instances. Those are the most important parameters when it comes to scaling, because these dictate between what boundaries we can scale. So you can see here that the minimum number of instances is set to 0. What that means is that whenever my deployment is idle, we will scale it back down so that it doesn't eat up any of your resources, so that you don't need to unnecessarily pay for something you're not even using. However, the very first time it starts up again, you have a small cold start, which will make it a bit slower when processing data again when it has been shut down. Sometimes you don't want that. When you want to put something behind a web app, for instance, it needs to be always available. So then you can just put that minimum instances to a higher number, and then there's always an instance available. And the maximum one is just to what limit can we scale? How many parallel instances can we have? Okay. I'm also going to run that. So I'm making that version, and then here I'm zipping up my deployment code, so that folder that I just made, I'm just zipping it up and also uploading it to UBOps so that it has the information about the version and also the code. So what it will do now, when we go back to the web app and we refresh quickly, does that work for you? That doesn't work with you.
Oh yeah, you should use the FN.
Ah yeah, no, it works. Okay, cool. So when we go here, we can see this building tag. So right now it's building, and what it's doing in the background is that it's taking that code that I just uploaded and those settings, and it's building a Docker container for me. So it's Dockerizing that code to make sure that it's reproducible, because I think you all know that whenever you have code on your laptop and you share it with your colleague and they run it and something completely different happens, and it's like, oh, it worked on my laptop. You know, like, Docker is something that makes sure that that doesn't happen, that it always has the same settings for everyone. So regardless of who clicks on the run button, it runs the same for exactly everyone. So that's kind of what we're doing. So that ensures that reproducibility part. And what we're also doing in the background is that we're putting it on Kubernetes. And Kubernetes is something that we use for scaling. So that allows us to really quickly spin up instances of your deployment, which can mean that when you have a lot of data traffic going to your model, that they can be handled in parallel, so that it goes a lot faster than when everything needs to go one by one. So that one's just building, and for this one, because it's quite a heavy model that I put in, it can take a little bit because it also needs to validate everything to make sure that it can actually run properly. And there's some security checks.
You could show the building logs to see that it's actually doing something.
That's true. When we go to the logs, we can see what's actually happening in the background. So right now, it's just installing all the dependencies I put. So when you have big dependencies, this step will take a bit longer than when you have small dependencies. Now, I think I have TensorFlow in there, so that's quite a big boy, of course. So it will take a couple of minutes to do this. And it actually already installed everything, so now it's just storing it. After that, it's going to quickly validate it, and then it's available. So that's everything that's going on in the background. Now, I can also run this, which will keep track of how it's doing. So if you're using a CI/CD pipeline and you want to make sure that you can only do something once it's already ready, you can also check the availability of the model through the API to make sure that that's all right. And I can also show you one that is already ready. So when I go to this one, so this is one that I already built yesterday, so that one's already done. Now, when I want to use this one, I can send data to it. So essentially what happened, what I got out, is this endpoint URL. This is essentially just a RESTful API endpoint that I can use now to put it together with other parts of my stack. So either behind a web app that I can send requests to it, or I can just do it through this user interface as well. So I can click Create a Request. And then I have two options. Batch or direct. Direct is synchronous. It's like for quick responses, typically responses that take a couple of seconds. The batch one is for things that are much longer running. For instance, if you have a training job, those can take a couple of hours. Batch ones can run up to 48 hours at the moment. So that's what you use when you have something that takes a lot longer. You can upload the file and do it. But we're actually going to do that via code as well. I'm going to check if the other one is already ready that I made. Yeah, it's available. So that means that we can get some sample data. I've got a couple of images here of a 1, a 2, and a 3. I think I should be able to show it to you in here as well. Or do I need to refresh? Oh. So we've got this 1 and this 2 and this 3. And we can send that over to our model. Yeah, there we go. Can I open this? Yeah, so here we have a 1.
Very small one.
Yeah, it's a bit small. A 2 and a 3. Okay, so if
Interesting.
Yeah, interesting Google Colab. Thank you. Okay, so also if I plot it, I think you should also be able to see it, because then we can actually send that one to the model that we just created and get back the response of what happened. So I'm also going to run the other sections. Okay, so it gives back the prediction, this is a 2, and I'm 100% certain of it. Now, when we go to the web app, we can also see that we did that. So when we go to our version, this was the version we created, we can go to the request tab, and there we can see what we actually put to this. So we can also check the image here again. Oh, that doesn't work for you, okay.
You can,
I don't know where it opens then.
oh yeah, from the browser, top right.
Can I just open that?
Yeah, it shows like a little, yeah.
Ooh. There we go. So we can see that we show that we put the 2 into the model, and that this is a prediction and a bunch of metadata to keep track of. So that's essentially now the full workflow that we did. We put this computer vision model with this pre-trained model on UBOps, and now it's ready to use. So I showed you how to use it through code through the Python library directly. You can also do it with the create request button or make a request schedule to it. If you have something that needs to run every first Monday of the week or something, you can also just define a request schedule that will make sure every Monday it will run. Any questions about this, about what I showed? Is that clear? See some nodding heads. Okay, cool. Yeah, oh, sorry, I didn't see it. I think you're like right behind the pole for me.
Yes, I was wondering, like, okay, now the API is exposed, but there you have to, like, when you are building API, you need to limit how many requests you can do per second, per hour. So how do I do that, or is there some user interface, or I have to do it in the code itself?
Okay, so for the rate limiting you're asking specifically. So we have some rate limits automatically, and we mainly have those in place for security reasons, that if someone decides to try a DDoS attack or something, that we rate limit it. Now, if you run into those rate limits when you're using the product, we can change them specifically for you. So that's something that we can do. It's not something you can control through the app directly, but if you already know, like, I'm gonna make thousands of requests to this model, we can just tweak that setting for you because we can change that basically per user or per customer. Yeah. Okay. Anything else? No. Yeah. No. I think it's for the recording that people on the recording can also hear it.
Project I'm working on has a Spacey pipeline, so that's an actual language library.
Yeah.
And we have a pipeline, and one of the steps is the model, and we have more steps in the pipeline. It's a whole code base by itself. How would you package that?
Okay, that's a very good question, which actually brings me to this. Let's see, I'll take this one. That maybe gives you an idea. Because something that I haven't touched upon yet is that you can actually tie these deployments together to create bigger workflows. Because of course, typically you don't have just the trained model. You have the data pre-processing steps, some post-processing. Maybe you have a certain part that needs to go in parallel, especially when you're looking at computer vision. Typically you want to tile that image because you have massive images, etc. So what we offer there is that you can make pipelines which look a bit like this. Where you can use or concatenate different deployments together to create bigger workflows that each then get its own API endpoint again. So this entire thing is abstracted as if it's one service again, even though you can swap out those parts and tie them back together in different ways. Here I've just got a simple one that has that picks up some input data from my Google Drive, sends it over to someone else's, and then writes it away to my Google Drive again. Pretty straightforward, but it doesn't have to be linear like this one. We also have a bunch of customers that have like super branched pipelines or that are putting certain things in parallel. This is actually something that we're also very actively working towards, but to answer your question, like how would you put it in here, this is essentially how I would put it in there. That you maintain those separate blocks you now already have in your pipeline and just put them also as separate blocks in UBOps. So that when you change one block, you don't have to change the entire deployment, but you can just change that piece of code. And it also helps in modularity, I'd say. Like you don't need to change it in all these parts of the code, but just one chunk. Does that answer your question? Or okay, what else?
Spacey library itself offers a pipeline.
Okay, yeah.
Where you really add the steps to like in the Spacey pipeline.
Yeah.
So it's actually
You can just add it in one big deployment as well. You can also do that.
Okay.
Because you don't have to do just one step. Like in the end, it needs to fit in this request function. But that request function can also call like 3 different scripts or call multiple steps of a pipeline, one after another. It doesn't have to be one thing. It's anything that can go in Python or R can go in that function. Yep. I saw another question somewhere as well, but I forgot who it was. Or maybe it already got answered like this. I'm not sure. Okay. Cool. Was there anything else you also wanted to still elaborate on this or not?
No, thanks.
Then we go back to the
I think we're good.
slides.
If also if you want to talk in more detail about service, or if you have a specific case where we also have a booth downstairs in the main exhibition hall, like right there.
Right there.
So come and find us and have a chat. And also, yeah, really looking forward to hear your feedback and thoughts on like model deployment. And yeah, hope you learned something, enjoyed the session. So thanks all for coming.